All right, so here we are, number 4. So this is going to ask you all about Coulomb's law and shielding. So remember in Coulomb's law, as the distance goes up, the energy goes down, and as the charge goes up, the energy goes up. All right, so first part here says, a student suggests that this pattern can be explained by using Coulomb's law for charge. Do you agree or disagree? So let's look at these guys here, lithium, sodium, and potassium. So remember, the charges come from the fact that you have protons. So here is lithium, sodium, and potassium. Lithium has 3 protons, sodium has 11 protons, and potassium has 19 protons. So potassium has way more protons than sodium or lithium, so its charge is up. So again, we're looking at charge here. So this is charge up, and this is charge down. So as you're going from here to here, your charge is actually increasing. But if you look at the results here, the ionization energy is actually going down. So our charge is going up, but our ionization energy is going down. That doesn't seem to make any sense, because if the charge goes up, the energy should go up. So consequently, there must be something else going on here, because it certainly doesn't look like charge can help explain the phenomenon and the data seen for these first ionization energies. So charge here is a big no. Can't do that one. Now, this one says, another student suggests that this pattern can be explained by using Coulomb's law for distance. Now remember, the Coulomb's law for distance says that as the distance goes up, the energy goes down. Well, let's take a look. Here's lithium. Remember that lithium is at the second shell, so we've got 1 and 2 shells there. Sodium is at the third shell, 1, 2, and the third shell there. And that potassium is at the fourth shell, 1, 2, 3, and 4. So certainly, as you are going down the periodic table here for these guys, so again, let's erase this. As you are going down the periodic table from lithium to potassium, you are getting larger and larger and larger. And so the distance from here to here is less than the distance from here to here is less than the distance from here to here. So we are seeing the distance increase as we are going from lithium down to potassium there. And as the distance goes up, the energy is supposed to go down. And is that what we see? Yes, that's what we see. As we go down the column here, from lithium to sodium and potassium, the energy is going down. So it certainly appears that distance can be used to help explain what is occurring in this particular problem here. And then finally, the final student suggests that this pattern can be explained by the concept of shielding. All right, well, remember, shielding is when inner shells of electrons get in the way of the nucleus's ability to affect its outer or valence electron. So if we take a look here, here's your nucleus. Your nucleus is trying to get to this outer valence electron in there. There's only one shell in between there, right? So there is one inner shell that is getting in the way of the nucleus's ability to see that outer electron. So there is very little shielding going on here. Now for sodium, that nucleus is trying to get to that outer electron there, but check it out. Not only is there one inner shell, but there are 2 inner shells of shielding. So there is more shielding. And if there is more shielding, those inner shells are running interference, and it's easier for this electron to be removed for ionization energy. And so if it's easier to be removed for ionization energy, it should go down, which is what we see. So yeah, looks like shielding is making sense here. Potassium, it's even more extreme. Here is the nucleus, and the nucleus is trying to get to that outer electron, but look at all these electrons that are in the way, that are shielding it. Level 1, level 2, and level 3. All three of those inner shells are getting in the way of that valence electron. So this guy has the most shielding of these three examples. And because he has the most shielding, that means the nucleus can't hold on to that outer electron very easily, and so it is more easily removed or ionized out of there because there is less attraction because of all of that shielding. So as you go down a column on the periodic table, you have more and more and more shielding, which makes it easier to remove that outer electron, which means the ionization energy is going to decrease. So again, to be clear, as shielding increases, your energy decreases there. So yeah, looks like shielding can be used to help explain this one as well. So charge, no. Distance, yes. Shielding, yes.